star key now. Please enter your chairperson passcode, then press pound. To start your conference, press 1. To change account option, press 2. You will now be placed into conference. For a menu of conference commands, press star at any time. You will now be placed into conference. The following conference commands are available. Press pound at any time to return to the conference. To request an operator, press star 0. To request an operator join your conference, press. The conference has been muted.
Okay, I apologize everybody. We are connected once again. Back to the diagram here. So we have this server, and I told you that we're going to be having lag configured on the server. So the lag could be LACP or static lag. Both works with MLAG. So we have switch 1 here and switch 2. And if you see number 1, it says the MLAG port, that is the local shared link. This is the one of the MLAG ports, and it has P2 on switch 2, if you see, which is number 7. That is the peer switches MLAG port. So these are the two links which will connect to the server, P1 and P2. And you can have either lag configured on them, so for additional redundancy, or you can have a single link as well. So that's one. And on, so if you see number 2, number 2 is the MLAG peer switch for switch 2. So the important thing is you have to understand the terms here, so that you get an understanding as I go through the other configurations, etc. So you get an idea of actually how MLAG functions. So if you see 3, this is one of the most important factors of MLAG. If you see number 3, we have the ISC, or the interswitch connection, which is the link between the two switches. So this can be configured as lag as well. So you can have one or more ports added to the ISC, or you can have just one link. So in MLAG, the switches communicate with each other. There are several reasons they do that. We will cover that after some time. So, but this is the link with which the switches communicate with each other. And on number 4, we have the ISC link we stated, which I just mentioned, which is also the interswitch connection. And at number 5, we have MLAG peer switch for switch 1. So for switch 1, switch 2 is the peer, and for switch 2, switch 1 is a MLAG peer switch. So it's important to understand the terminology here. So at number 6, we have the ISC ports, or the interswitch connection ports, which are basically the ISC ports which you are going to add as lag, or if you have a single link, that is what would be used. And at 7, we have MLAG port, which is a non-load shared link. I told you that you can when configuring MLAG, you can either have the ports as a lag, or you can have one or more ports bundled together, or you can have a single port as well. Uh, I've included both these here. Actually, if you see on switch 1, P1 is actually a load shared link going to the server, and on switch 2, if you see P2, it is a single link going to the server. So you can use both actually, and you can use them together as well. So that is 7. So on 8, we will see this is also an important part of MLAG, which is the MLAG ID. So on both the switches, on switch 1 and switch 2, so that they are able to communicate with each other, we need to configure something called as an MLAG ID. So the MLAG ID on both the switches should match. So that's how they understand that they are synchronizing with each other, and that is what helps them to identify each other. And at 9 we have MLAG remote node sees the MLAG ports as a regular load shared. Um, Sees the MLAG ports as a regular load shared link. So at 10 we have MLAG remote node. As I was explaining, you can for MLAG you can either have you can configure MLAG with a switch, or you can have MLAG with the server. So on the server side, you would generally be configuring NIC teaming, and on with switches, you would be generally doing LACP or static lag. Uh, so we'll go to the next slide here. So as I was explaining about how MLAG works, this is basically uh, how it works. So we'll go back here to the diagram so that I can explain what exactly happens. Uh, so on the server end, as I mentioned, you would be configuring teaming, and so the server sees both the switches, switch 1 and switch 2, as a single switch, and if you're aware how lag works, it works on an algorithm, and based on that, it chooses the ports that it needs to send the traffic through. So it does not know that it is connecting to two different switches, and hence it is going to be sending out the traffic through any of the links. And the switch 1 and switch 2 will synchronize their forwarding databases. One important thing to note is that MLAG can be configured only on exhaust switches. They are not supported on EOS switches, Entrusted Operating Systems, or any of the other vendors. It is extreme specific. On the remote end, like the server end, it does not matter. You can use any of the vendors, but for in the place of switch 1 and switch 2, you need to have exhaust switches. We'll see what are the switches as well that can be configured for MLAG. So as I mentioned, both the switches, switch 1 and switch 2, will synchronize their FDB databases, which is the forwarding databases, and using an access list, it will actually drop the traffic, which is, we basically have a redundant connection here. So we have possibility of a loop. So, but the loop was prevented using access list. We'll see how exactly that happens, and that happens using a additional diagram. So I was explaining about MLAG ID. So this is basically just how it is. So this feature is actually brought in to prevent uh, layer 2 for it's basically for layer 2 deployments, but it will also work with layer 3. Uh, so most of the time there is no traffic traversing the ISE, that is dropped by the ACLs, uh, so that to prevent network loops. And sometimes the ACL will also block the redundant ports on the switches to prevent the loops. So the switches communicate with each other using UDP as a keep alive mechanism. So the switch 1 will send a keep alive message to switch 2 to inform it that it is alive. And based on whether the ISE is uh, based on whether the switch or the link goes down, the peer switch will actually open or block its ports. We'll see how that is. So I had mentioned that both the switches will synchronize their link states, the MAC FDB and the IP multicast FDB. So uh, they synchronize the FDB using TCP connection, whereas the hello message for the hello messages they use UDP. For the FDB synchronization, they use TCP connection, and this TCP connection uh, is maintained over the ISC VLAN or the ISC link. We also need to configure an ISC VLAN for it. I'll explain that as well in a short while. So there are two types of convergence control modes which are supported. One is fast convergence, and one is the conserve access list. Fast convergence is what happens is I told you both the switches maintain an FTP table, and uh, as soon as a link goes down, the if I come to the diagram here, so let's say the link P1 on switch 1 goes down. So the only redundant path is the ISC link. Let's say there's traffic coming in from the internet, which looks like a cloud here, and we have the P1 switch, I mean the P1 port on switch 1. And just in case if that goes down, so the only other path, I'm sorry, today the network is pretty bad. Actually, I've lost connection again. I'm sorry, let me just connect back again.
Welcome to Ready Access by Level 3 Communications. Please enter your access code, followed by the pound sign. Thank you. Please stand by. If you are the chairperson, press the star key now. Please enter your chairperson. To start your conference, that entry is not valid. To start your conference, press 1. To change account option, you will now be placed into conference. For a menu of conference commands, press ** at any time. You will now be placed into conference. The conference has been muted.
Hello. I hope everybody can hear me. I'm sorry, today the network is causing a lot of issues here. Not sure what happened. You can, if anybody's got issues, just please let me know by chat. I hope I'm audible now to everybody. Okay. Uh, Thank you very much. Apologize once again. This is it's a nightmare when you have network issues. So let me go back. So I was left off here. I was telling you. Okay, I was explaining about convergence, and so we have two switches here, switch 1 and switch 2, and let's say we have traffic coming in from the internet, and for switch 1, the port P1, which is shown in the diagram, let's say that port is down. So switch 1, the only other way it has to reach the server is through the ISC link, which is the interswitch connection between the links. So in the FDB table, the switch will be having an entry with P1 port, which is the connection to the server, and the VLAN ID. So the switch needs to switch over the traffic from P1 onto the ISC port, which is 6. So with fast convergence, what happens is without the switch just sends whatever traffic which is destined to P1 onto the ISC link with when you have fast convergence on. Uh, So and the other convergence control mode is the conserve access list. So one I told you fast convergence. With fast convergence, you the switch just forwards the traffic onto the ISC link. Uh, so it helps to forward the traffic immediately, so there is no delay. Whereas if you are not using fast convergence, you have to use conserve access list as the mode, in which case the traffic will have to be learned first on the ISC link, and then the traffic will be forwarded. So that can cause some delay. So it's always better to have fast convergence. You can use conserve access list when you do not want your access list to be used, where you have you have hardware limitations and etc. You would use conserve access list, where you want to limit the number of access lists on the switches. So as I mentioned, MLAG is supported only on exhaust switches, and these are the platforms that support it. So BD8K, all the BD8K switches supported except the original series that were launched. I'm sure nobody's using those nowadays. All the Summit series switches, the Summit switches like X450, X460, X670, 650, all the summit series switches, and all the summit stacks as well. So if you're familiar with summit stacking, so it's nothing, just the summit switches, the standalone switches can be stacked to act as one single switch. So all these switches support MLAG, uh, and the ones on which MLAG is not supported are the BD20K, BD10K, and the BD12K. Most important thing while configuring MLAG is that both the switches, the MLAG peer switches, which I was mentioning in the diagram, should belong to identical platforms, which means you cannot have one MLAG peer to be a BD8K and the other MLAG peer to be a Summit series switch. Both have to be same. So if you are stacking Summits, you stack only the Summit series switches, or if you're doing a stack, you need to have a stack itself. Or uh, if you have a BD8K on the peer MLAG switch, also should be a BD8K. Uh, Next important thing guideline for configuring MLAG is that uh, you can have a single link between the ISC, uh, but the recommended setting would be to have uh, 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 lag ports, which can be static, or LACP also can be configured. You also, another thing to important thing to know to note is that the ISC link should have sufficient bandwidth. So use links with higher bandwidth for the ISC. And during the configuration, the important thing is on the ISC also you would be configuring all the VLANs that belong to the MLAG, or the for example, if you see on the diagram, the links going to the server that could be part of one VLAN, and so on the ISC, that VLAN should be configured on the ISC ports as well. So for L3 forwarding to work with MLAG, you need to have VRRP or ESRP configured. So basically, you'll have, like, if you have a core 1 or core 2, you'll have VRRP running on both the switches. So it can be configured on active-active, which means both the switches, the core 1 and core 2, will be in an active-active configuration, and traffic will be forwarded through both the switches. I will explain how that works in a short while. Uh, so the limitations is to the MLAGs is that you can only have one peer switch. You cannot have multiple peer switches, but you can have different MLAG IDs, or the number of MLAGs that can be configured on a switch is 768. So you can have several different MLAG sessions running, but the peer switch can only be one. And you can have a number of ports that are working in an MLAG will be 68 on each switch. So if you have two switches, the number of MLAG ports participating in a number of ports participating in MLAG would be 128. So you have 64 on each switch. So this will show you exactly how MLAG works. So refer to the previous diagram itself. So you have switch 1 on the left, switch 2 on the right, and let's say you have a server configured below, and you have so for this example, we've taken both the switches from the server 1 will have lag configured on it, going to two different switches. So if you see, let's say we have the blue lines, which is the blue VLAN, and the green lines, we can call it the green VLAN. So on the blue VLAN, if you see on during normal operation with MLAG configured, if you see on switch 1, P2 is the link going to server 1, and on switch 2, P2 is also the link which is going to the server 1. So you have and this same VLAN will be configured on the ISE as well, so you have a redundant path. On during normal operations, say we have traffic coming in from the internet or from the cloud, so traffic comes in through P4, and if mm, if the traffic is being flooded, uh, uh, let's say there is no entry for a particular VLAN, the switch does not know where the particular destination is. It's going to flood the traffic, and so when it is flooding, it's going to send it out through all the ports on the switch. So switch 1 is going to send out the traffic to all the ports, which means P5, P1, P2. These are all the ones which are ports which are belonging to Blue VLAN, and so it's going to send it out through all the ports. And if you see on the peer switch 2, the traffic is going to come in through the P1 port, but to avoid loops, what will happen is the P2 port will be blocking to ensure that the loop is not created. So that traffic does not come down through switch 2 to back to the server. So it does not receive duplicates the server. To ensure this, uh, the P2 port on switch 2 will be blocking. So this is how the flooding traffic is blocked. So this is for next scenario is for unicast forwarding. And for this we will check an example using the green VLAN. So similar in the previous case, it is a unicast traffic, and switch 1 is receiving the traffic from the internet. But if you notice here, we've just let's say I've given a scenario here where let's say P3, which is the port on switch 1, is down. So if the port on P3 is down, generally, and if you got fast convergence on, the traffic which is coming into switch 1 it will be forwarded through the ISC link, and since it is unicast traffic, it's going to be sent only to the port P4 towards server 2. So it's coming in through P4 on switch 1, going through the ISC onto switch 2, and it's going to be forwarded through P4 onto the server 2. Uh, in case the link here, let's say P3 on switch 1 was not down, the traffic would have come in through P3 itself directly to the server. So depending on the scenario, the ISC blocking filters would come in, and it is all automated, so we do not have to worry about it. The ISC blocking filters will take over the responsibility of blocking all redundant traffic onto the different ports on the different switches. So they, as I told you, both of them synchronize each other with each other, switch 1 and switch 2, so they are able to synchronize the FDB as well. So this is happening. In this example, we'll see how L3 unicast packets are being sent out. So we have switch 1, which is generally how we have configured. Switch 1 acts as the VRRP master, and switch 2 is the VRRP backup. So sometimes the L3 traffic may also traverse the ISE, like in the case of L2 as well. So so we have, and we have an ARP request going out to say probably the master or the firewall. So from the server is actually making an ARP request, and that ARP request is going out through switch 2 and going out through the ISC link onto switch 1, which is the master, and only switch 1, which is the master, responds to the ARP request because it is the VRRP master. So any ARP requests for the master would be responded by the master, but it does not, the reply does not necessarily have to traverse the ISC link. Instead, the VRRP master sends the reply directly back onto the server through P1, which is the switch 1 port P1. It sends it back through P1 to the server. So this is how the L3 traffic gets forwarded. So we'll just go through a few commands for MLAG. I have this is just a tier 1 MLAG which we just showed you how it works. We can go in for tier 2 MLAG as well. I will explain how that works. So the commands to use for creating an MLAG peer is create MLAG peer. And okay, one more thing I wanted to inform is that where what I wanted to explain is the ISC part. So you do not specifically mention during the commands about the ISC VLAN. So if you see in this here in this diagram, so for the ISC VLAN, it is a normal VLAN that we create. We just call it the ISC VLAN, and the switch understands that it is an ISC VLAN using a command using the MLAG peer and the MLAG peer IP address. If you mention it, this is how the switch understands, and using the MLAG identifier command. So using these, it identifies that uh, the peer is the ISC is actually, which is the ISC VLAN. That is how it understands it. We will look at those commands as well again. Another thing you would configure is you will configure an IP address on both the switches. This is how I told you it maintains the TCP connection between each other. So on one peer, you would give the an IP address in the same range as the other, and the command to give you an idea about how MLAG is configured, you would be show MLAG peer. So on the so if you see on the left hand side, you have a MLAG peer switch, and the VLAN is the ISC VLAN, and the IP address is 10.1.1.1, and the MLAG ports, how many MLAG ports are configured on it, and whether checkpointing is enabled. And on the right side, you have the peer IP address and the transmit interval of the switches. The hellos can also be configured on both the switches. The timers can be changed. So another command to check the MLAG status would be show MLAG ports to check which are the ports belonging to MLAG. This is not the ISC VLAN. This is just the MLAG ports. The commands can also tell you whether the peer ports are up on MLAG or not. So this is we just went through tier 1 MLAG. So similarly, you can also have a 2-tier MLAG, and basically the functioning is just the same. Only thing, the configuration commands would vary a little. So in this setup, we have 4 MLAG IDs which are configured. So down below, if you see, we have the servers which are configured for MLAG, and both the servers are running MLAG ID 3 and MLAG ID 4. And then we have two switches, the X650 switches, uh, which are configured with MLAG, and the ports 8 and 9 on 651 connects to one of the servers, and 8 connects to one server, and 9 connects to the other server. And on 652 also similarly, uh, 8 and 9 connects to both the servers. The only difference in tier 2 MLAG is that if you see the BD8K1 switch, if you will see, it mentions the ports 3:1, 4:1, 3:2, and 4:2. All the ports will be configured as lag ports. So on normal MLAG, when you see, you would generally be having only just one of the links configured as lag. But here we join all the ports together on the BD8K one. We join all the ports together in a lag, and that is how that's the only difference we will have. But the function, everything else is similar. So even we have an ISC VLAN configured on the between the two BD8Ks, and similarly on the 650 also we have the ISC VLAN configured. And MLAG ID 1, 2, and 3 and 4 we have. So we are also running out of time. So basically, there's not much difference between the I mean single-tiered MLAG or tier 2 MLAG, as I told you. So if you will look here on BD8K switch, we are if you see the last commands, so which is the enable sharing 3.1 grouping. So this is the difference I was talking about. Only thing is that uh, you would configure all the links under uh, under lag for in case of tier 2 MLAG. And so if you see on the BD8K switch 2 as well, you have all the links that are configured as lag. That's the only basic difference that you have between tier 1 and tier 2 MLAG. So I can share the configuration for you. In fact, we are recording this, so we can, if anybody wants, we can share it, and you can verify the commands, etc. So for LACP people who understand LACP and how it functions, um, I had another important thing to remember while configuring MLAG is that even if you have a single link to a server or to a switch, the important thing to remember is that you need to configure lag on it. So if you say uh, enable sharing, say if you have only one port on the lag, so you will say for port 1 you will say enable sharing 1 grouping 1, so which means only one port will be part of the lag, but you need to enable mm, sharing on them. That is because on the server side also, whatever you are configuring, say you're configuring LACP or static lag, you need the same should be configured on the switch side as well. So for that, since you're on the server side, you're configuring teaming or LACP. So because of that, on the switch side also, whatever is configured, on the switch side also it has to be configured. Many people generally forget to do this, and their MLAG does not come up. So even if you have one port, just enable LACP or static LACP depending on what you've got configured. Uh, so the LACP system ID. So the server, for example, is considering both the switches to be a single switch, and so the same MAC address is showed to the server. Uh, so there are two options for this. One is the switch with the highest IP address will show its MAC address as the system ID, or it is also user configurable, and the one you can configure which switch MAC address should be displayed as the system ID. And for the LACP actor key, it's a similar. The one with the highest IP address on the ISC will form the actor key for the LACP bundle. And no LACP PDUs, protocol data units, will be transmitted until the actor keys are checkpointed. So we've reached the end of the session, so we'll just go through a few question answers that we've prepared. Uh, so what are the models of switches on which MLAG is supported? So the options would be S series, BD8K, Summits, and Summit Stack. Anybody wants to think about it, you can think about it. So the answers would be BD8K, Summits, and the Summit Stacks. The S series switches are Entrus's operating system switches, so they will not support MLAG. So question 2, MLAG peers communicate with each other to synchronize link state, MAC FDB, and IP multicast FDB through which of the following ports? MLAG ports, ISC ports, lag ports, or uplink ports. So I had mentioned that to synchronize the MAC FDB or IP multicast FDB, it uses a TCP connection, the peers, and it uses the ISC ports to do this. So the MLAG peers communicate with each other using the ISC ports. Uh, the ISC ports can be a lag, so it's recommended to use a lag for ISC. So what protocol does MLAG use for sending keep alive messages to peers? TCP, ICMP, UDP, or ARP? So I told you for both switches to be aware that the other is alive. They send uh, keep alive messages, and for this UDP is used. So only for synchronization TCP is used, but for the keep alives, UDP is used. UDP is user datagram protocol for people who are not aware. So the fourth question is, what is the maximum number of MLAGs that are supported on a switch? So the answer for this is 768. That's the number of MLAGs that are supported on a switch. So with this, we've come to the end of the session. I thank all of you who have joined, and I hope it has been useful for you, and for it will be useful when you're configuring or setting up MLAG in your network. I hope so. If anybody wants any information, you can send it to me on my email address, which is there in the email, or you can call me directly for people who are aware. So thank you, and thank you for this session. Hope you guys have a good day. Bye bye.